And our next speaker is coming online here, Zach. Hi, nice to meet you on the internet.
Hey, Paul.
Zach's going to be talking to us today on the subject of ETL and ELT, a subtle distinction which you'll no doubt be clarifying for us, transforming geospatial data processing with PostGIS and DBT. Over to you, Zach.
So thanks, Paul, for the introduction. I'll share my screen. All right. So here we go. All right, everyone can see my screen. Just exit this. All righty.
Yep.
So today I'll be presenting from ETL to ELT, transforming geospatial data processing with PostGIS and DBT. So thank you, Crunchy, for hosting the event. It's really awesome to talk so far. So I work for Anagraph. We're also DBT partners. So a lot of the content that you'll see in the slides today is actually made by DBT, and we got their authorization to share it with you. So our game plan for today is I'll give a quick intro of Anagraph, then explain why DBT and how is it relevant in geospatial, and then move on to a short demo. So it's going to be pretty jam-packed. I hope that I can fit it in. It won't be too deep into PostGIS, not too deep into DBT, but hopefully the intersection of both will be interesting. So Anagraph, I'm a product manager for them. And what we do is we help change how people solve problems. So we really believe that everyone can leverage geographic intelligence. And we're a service company that designs all of our services with empathy, creativity, and curiosity. Concretely, what does that mean? Well, we're a one-stop shop for people who want to create user-friendly, beautifully designed, and performant geospatial web applications. So what does that look like? Well, generally, it's these really simple, easy-to-use interfaces that transform location data in some shape or form and help answer specific questions to users that are usually not your traditional GIS analyst that uses desktop GIS. So we work with a range of different verticals, from real estate companies, from bread makers that want to open up a new franchise and that need help doing site selection. Yeah, and even bigger companies like insurance companies or even banks. So in this example right here, it's our just site selection. So visualizing different data sets and allowing users that are not necessarily technical to see their data on the map and also answer these really niche and specific questions together. So this is a location score where someone can actually change the weights that are associated with each and move up. All right. Move on to the next slide, get back in there. Okay, so what we do is we help teams design, deploy their infrastructure in the modern cloud, integrate their data and third-party data into that, and specifically build products. So while doing that, a lot of the work in geospatial is focused around data. So we end up changing our tools and how we work. So anyone who's worked in GIS probably knows some shape or form of ETL tools. So you have FME, you can also think of QGIS with Model Builder, or even Esri's version with, and it's all pretty much the same, where you take input data sets, you apply some transformations, you get an output layer, and you keep on processing them as you go in. And if you're at this talk, you probably already heard or used PostGIS. And PostGIS is great because you can transform your data into code, you can get better performance, you can link your different processes together. You get all the benefits of a GIS without a traditional GIS. But that doesn't say that everything's fine and easy to maintain in time. So generally speaking, large processing SQL files are pretty common. So I've been having a lot of fun recently on GitHub doing searches and looking at specific queries. So figuring out what's the file size of public code available that has a geom or select within it, and then looking at the distribution of that code in time. So we can actually see that a lot of test files can go up to 200,000 lines of code, which is huge. And even if we look at the shorter tail of it, we can see that there's a large amount of public code that has way above 500 lines. And that always stunned me because it makes maintaining those making code bases in SQL really hard in time. We're working with these really large files, a lot of number of files, and it can become tricky when it comes to actually maintaining that in time. So a solution that we've used and that I know a lot of people have used is connecting it to some other code base that has a framework for testing documentation. So the traditional approach is using PsychoPG with PostGIS, and I've seen that a lot going on, and it's pretty popular. So there's over 12,000 hits for searches on GitHub with this. And the problem is that usually it's really hard to test. It's hard to get data from that connection, bring it back in, and then move it along. We can also think about, so data engineers actually become pipeline tool maintainers instead of just data engineers that are focused on solving problems or building data products. All right. So cloud warehousing actually changed how transformation is done. So in the ETL framework, what we traditionally do is we start with our raw data sources, we apply all the transformations that we need, and then finally we load them into the database. And in the ELT framework, instead, what we do is we extract the data sets, then we load them into our database. And from that warehouse, we actually use our warehouse as the computing engine to go and from where our BI tools will eventually get the results. So there's a lot of jobs that are actually happening. And when we talk about data processing, it's not simply extracting, loading, and transforming. We also want to expose that to downstream consumers. We want to automate our processes. We want to be able to do data quality tests. And we also want to be able to document that. And if we look at the difference between ETL and ELT, when it comes to buy or build decisions, one framework I like to use is called Worldly Maps. And it basically classifies them on whether the element is visible or not to an end user and how mature it is on the other axis. And one thing I like to see is that with ELT, by pushing things into the warehouse, what we get to see is that a lot of things are pushed into the product commodity side. So when it comes down to testing, documentation, or even metrics. Yeah, so the DBT viewpoint and our viewpoint at Anagraph is that SQL is perfect for data transformations, and it helps us work like engineers. So when it comes to modularity, testing, CI or CD, it's much easier to maintain code bases in time using this framework. So what that can look like, well, we start from our raw data sets. We're able to push that into a development environment, add our tests and documentation, and finally deploy it into production where end users can go and consume those data sets and run analytics or visualizations, et cetera. So DBT is tremendously popular in data engineering. It's been growing steadily over the last couple of years, but its adoption really lags in geospatial. So if we look in for specific SQL files that are found within the folder models, which is the DBT's project structure for every transformation step, and looking for specific queries that are involved, something like PostGIS or another spatial database, there's only 34 public code hits. So it's something that's very new compared to using PsychoPG that had 12,000 code hits. And there's a single question about PostGIS and DBT on Stack Overflow. So why would we use DBT? Well, we can develop faster, we can test things faster, and we can deploy faster. So since we adopted DBT at Anagraph, we've been using it on all of our projects, and we've seen tremendous gains when it comes to refactoring code bases, building new ones, and deploying them. So DBT Labs actually have DBT Cloud, which is like the cloud version of DBT. I'll be talking about DBT Core mostly because it helps us review kind of the fundamentals and how the tool is structured. So there's a lot of things you can do with DBT Core. You can run your ELT pipelines. You can use Jinja templating to add some custom logic into it in a fashion that's pretty similar to anyone who used Django or certain languages, certain tools in Python. You can compile that Jinja templating directly into SQL and use that directly on your database. You have multiple adapters, one for Postgres, and if you use it on a PostGIS enabled database, then you can use spatial queries. It gives you an easy framework to use for testing and also documentation. So a technical overview of how DBT works before diving into the demo. So our general flow, if we break it down to the simplest terms, is we start from our raw data. And then we load that into our database. Once the data is in our database, then we're applying these transformation pipelines. And finally, we have consumers at the end of that. So usually it's PG-TileServe we're gonna use that as an endpoint to go and read to build our front-end applications. It can also be data visualization tools or other data processing queries that are going to go and use directly our database. The DBT can be broken down into 3 main commands, at least when we're getting started. So run, which actually executes the transformation pipeline. Tests, which executes the tests defined with our profile models. And docs, which generates our documentation. So those are the 3 core ones. There's also 2 other ones. So we can use deps to install any defined packages. So there's an open source ecosystem around DBT where people develop these custom packages that you can install, and it makes writing DBT models a lot easier and applying engineering principles like don't repeat yourself and other things like that. And compile finally if you want to generate the actual SQL to be able to run the Jinja templated models directly on your database. Okay, so you need 2 things to run DBT. You need a profile, so that's where I'm going to connect to, what warehouse I'm going to connect to. In this case, it's a PostGIS enabled database. We can also use Jinja templating to configure our environment variables so that we don't have to actually store any hard-coded things directly within our code base. And we can also and you also need a project structure. So you need your DBT models and your DBT profile to be able to run DBT. So a DBT project is composed of a couple of elements. The ones in bold are the most important. So the core component is our models, which is the actual building blocks of our ELT pipeline. And then we have our tests, which are actual SQL files that are going to put into the tests folder. Then there's our project configuration file, where we're able to do some really advanced things, such as run specific actions once the pipeline's finished. So you could grant access to a specific role to all the models, all the tables within a schema, for example. And finally, we have our schema.yaml, which is the centralized point to write all your documentation and configurations for each model. Finally, there's the macros, which are reusable functions that you can define and customize yourself. And there's some other elements that I won't get into because we're short on time today. So at its simplest form, a DBT model is a SQL file that you can put into the models folder. And a select star is a model. So select star from your certain table, that becomes a model. And when you're going to run the pipeline, it's going to execute. However, you can also do more advanced configurations. So for example, right here, my model has a config element where I'm saying I want to materialize the model as a table. You could also say as a view, or there's 2 other materializations that are a little more advanced. And you can also define on what indexes you want to create. So in this case, I'm creating indexes on an H3 ID and on the geom column. You can also do some post-hook actions. So after that model is created, you can run certain actions, whatever you want. But the core element and really what makes us be able to build data pipelines with DBT is the reference keyword. So the reference keyword says that this model specifically depends on another model called local pop. And that's what's going to help us generate some beautiful documentation, organize the processing steps of our data pipeline also. And it's really the fundamental element to DBT. You can also have tests. So you have singular tests. So for singular tests, the convention that DBT put in place is that if 1 row or more is returned, then the test fails. So in this case, I'm verifying that the local pop is actually of the H3 resolution 8. And yeah, and you can define it. So as soon as 1 row is to be returned, then that test would fail. You can also have generic tests. So generic tests are a macro where, right, for this one, I'm verifying that the geometry will be able to be read by PG-TileServe. So there's documentation that you can auto-generate. In this case, it's a real simple example, but we've been using it in all of our projects. So we have a couple of different examples, and the structure can be very different from one to the other. It can be as simple or as complicated as you want it to be. So every single step that you're seeing here is a DBT model with the reference keywords allowed to create that lineage together. And I'll get into a more detailed example interactively during the demo. And finally, you have macros where, for example, we can convert a string to a double, or we can do, again, another generic test macro. In this case, we're verifying that a specific role is able to have read writes to a table. So in this example, we built tests so that to verify that our models can be read by PGTalServe. So in that case, we're always served at our downstream consumers. Our data models, our DBT models will match the requirements of our downstream consumers. And finally, you have the schema.yaml. So this is how we link our documentation. So this is a specific model, and I gave a very limited description to it, but we could have given a very long description. You can define owners for each model. You can define your tests, and on this time, the test is defined on the actual model level. So at the higher level, we can have tests that are run on specific columns also. And yeah, so that's how you're able to link your generic tests directly with each model, and it becomes highly repeatable. So I don't need to write a specific SQL command every single time that I want to run a new test. So again, running actions at the end of pipelines is all possible. And you can also have configurations directly in your project to say, well, all the models that fall within the folder by default will have indexes created on an ID and on a column job. Okay, so that's a 101 overview, giving a lot of information. I'm going to dive in directly to a demo. So for the demo, I was inspired by the work done by Leonardo Nicoletti recently on the city access map. So he made publicly accessible a lot of the data preparation and data processing he did. And he also created this really gorgeous front-end work where you can understand how accessible your city is. So I kind of dived into the work he did with the OSM points and tried to convert that into a DBT pipeline and start playing around with it. So, okay. I'm going to move over this. Okay. So the first thing that we use, if we think about our flow where we move from our raw data sets over into our database and then apply the transformations for the downstream consumers, is we use a tool called Yogurt that we worked on. So one thing that we really like about Yogurt is the fact that it gives us this central point that where we can document all of our data sources. So for the demo, I'm using the POIs, the POI groups, our local pop, which is a model, population model in Canada, and the population centers. That's generally how it, the data sets that we're going to be using today. And to run Yogurt, it's a really simple command. So we simply run Yogurt run our profile, specifically the sources file and our secrets file, and that will import all of our data sets into the database. It's a really simple OGR to OGR wrapper, nothing super complex under the hood. It just limits the options available to the user and makes it a little easier for us to use. So if we move into what a DBT project looks like, I think the easiest way to show this is by going into the models folder. So we have our DBT profiles, which shows our connection as we showed before. And the other element we need to run a pipeline is our models. So we have our macros, which are our reusable code bases. We have our models, and we have our tests. So if I look within the models, I made a specific folder for today for only BC instead of just Canada, so that it runs in a reasonable amount of time. And we also organized a second folder called with the tiling, which holds the models that we want PGTalServe to be able to read from. We also have some other ones that are unclassified at the root. And finally, we have our schema file that has all our documentation. So if I show what that schema file looks like, we can see that we have all of our, there we go, DBT project, and models, and then, okay, there we go. So you can see I defined two models. So the H3 ratio POIs with its description, and then we have its tests again to verify that PGTal server will have all the rights and necessary requirements so that it can read from this. And we also have the population centers that I configured in the same fashion. So I'm reusing these generic tests every time to be able to run it. So if we get into actually using DBT, I'm going to show a couple of commands. So the first one is around documentations. So we can generate the documentations from the schema.yaml by using the command docs_generate. And if I specify the project here, which is what we need, so it's DBT project, and I need to specify my profile, which is DBT profiles, and I press enter. So this command will generate all of our documentation. So it wrote its documentation, and then we can actually go back and spin up a server, which will host it. And surge. There we go. So it's spinning up the server. There we go. And I can actually go into it. So this gives us the navigation panel and explains what we can do with it. And the first thing I like doing and using is looking at the DAG, the interactive DAG. So this is what we can use to kind of see what the relations are between each. If I click on one, we can see the highlights. So for the BC example that will be running in a few short moments, we can see at the end we're generating the population centers with all the additional POI counts and that have been aggregated. And yeah, you can dive into details directly into the model. So we can see, for example, for BC, there's some really more advanced processing that we did. So we can use Jinja templating to actually set an array, and if that use that array in loops, we have our reference keywords that are going on. So this is a complicated model where we're counting the number of POIs by category and creating these aggregation counts for each. And what's pretty cool is that we can, again, configure all of the materializations, the column indexes, and we can move on and see the compiled results at the end. So all this is available for each layer. If I go into the population center, we can have we can see what models reference it. We can see what tests are run on specific folders. You can, again, see what the compiled result is. If I look at the tested centers, then we have its description that's provided. You could add descriptions to each column if you wanted to run specific tests on each. Yeah, and you can see also what tests have been run on this one right here. So there's a lot going on. There's a lot that's possible. So that goes for documentation. I'm going to show now if I actually run the model, what it looks like. Because we're limited on time, I won't run the entire model. I'm just going to run the BC subfolder. So the command for that is dbt run, and then we're specifying again our project here and our profiles there. And now since I want to select all the models within BC, I need to add the select keyword and then the models folder. So when I run the dbt pipeline, what actually goes on is every single step is executed. With our reference keywords, it knows in what order to run them specifically. So we can see it ran all 5 table models. So right here, we're creating H3 grids and aggregating those points and creating different ratios based on the population data that we have. And finally, we can run our tests. So the testing command, instead of run, I'm going to specify a test. And I actually don't want to run the selection because I want to run the test on the entire pipeline. And for those that are familiar with PyTest, it might seem like any testing framework pretty similar. So you can see every single test that was run, whether it passed or not, and that's pretty much it. So when it comes to visualizing some of the results, what we can see, for example, with PGTal serve, that the layers that we wanted to create around the tiling, so the ratios, we can see that it was available and now accessible, and we already have our tests in place to make sure that that would have been the case. Something else, if you want to see the results more visually on the map, well, we have our population centers on which we aggregated some counts, and we can add our local pop data set on top of that, which is our population data set that we use to aggregate, and again, the POIs at the end of that. So it gives this flow where you can visualize with QGIS and have all of your processing steps all in one. All right, so if I go back, there it is. And again, you can have other types of consumers, so we can run that analysis. So if you're thinking about the format that you need for analysis, you can move on directly. Yeah, so this is probably a little bit of a whirlwind, a lot of information. I didn't dive deep into PostGIS or into DBT. So where can you start? I would start by looking at the DBT's documentation directly. You can also look at our blog. We have a couple of articles on using DBT with PostGIS. And if ever you have questions, feel free to email us or reach out. I'm a little less active on Twitter recently, but on LinkedIn, I'm a little more active.
All right. Wow. Thank you very much, Zach. That's a really cool project. And I can see how if you're managing data at all or data flows at all, super useful. And it's lovely to see it, working inside the database, not necessarily having to haul all the data out of the database in order to do its work. I noticed you have this materialize keyword.
Yes.
Like if you don't ask it to materialize, like what does it do? Does it change CTEs? Like what happens?
It'll use your default materialization that you defined in your project configuration.
Okay.
So I think by default, that's table. The other materialization is view, so it'll create view. There's also an ephemeral keyword, which basically will compile your SQL into a common table expression in every reference model afterwards. So every model that depends on it will have that insertion of your SQL logic into it. And there's also an incremental model, which we haven't used that much, but it basically will, if you have a keyword on which you can verify which rows it needs to update. So it won't actually rerun the entire model every time.
Right. Does it work with like crazy things like foreign data wrappers?
That's a good question. I haven't tested it out. You should look into it.
Postgres is the integration environment after all. It's where everything comes together and where you run your chains of data and logic. Do we have any other questions now? Nope, doesn't look like it. Okay. Well, thank you again, Zach. This was a great talk, and I really appreciate hearing how you're working with data.
Awesome. Thank you, Paul. Take care.